Hello! Today in class we will solve examples where we convert sums into products. For this we will utilize factorization. In the previous lesson we solved an example where the variable part was in power form. Today we'll solve another example like this, and we will use the rule we applied in factorization. Let's recall the rule. The following example is 16, a squared b squared minus 32, ab squared plus 64, abc squared. For starters, I want to focus on the coefficients. Notice that the coefficient equals. You often ask this question. 16 is 8 times 2, it's 4 times 4. How should I write this coefficient? To avoid mistakes, first, remember the following rule. Choose the smallest number or the smallest coefficient. In our case, it is a factor of 16. And try dividing the other ratios by the number 16. 32, we can divide by the number 16, yes we can. 64, we can divide by 16, yes we can. If we can do this, then we will base our work on the factor and write it down. 16, a square b square minus 32. We agreed we'd write it down as 16 times 2. We will rewrite the letter part, then 64. If there is a number 16 in the first summand and in the second summand, then let's write 62 as 16 times 4. Pop, and we'll rewrite the letter part ABC. Now we see which in the first summand 16, in the second and in the third. Now let's look at the letters. Please note that we have the letter part written in the form of an exponent. In our last lesson, we discussed that if we encounter identical letter components that include powers, then we take the common term, the smaller degree. Notice the common factors. These are the multipliers that are represented by a letter. Oh, the square of A and also Passa. What multiplier? What smaller degree? It's clear the second term's A is to the first power. In this situation, the degree is 1. Thus, out of the parentheses, I'll take out 16 and first degree. Then we'll note the next expression in brackets. A squared existed. There were 2 a's. We took one a. Therefore, in parentheses, there remains a and b squared. We removed minus 16 from the parentheses. There are 2's left. We took b squared. 2ab squared. In the third addend, we take 16 and a. As a result, we have 4 b's left. Yet, notice that we can also see a common factor in the parentheses, b squared, and b. Let's take out b to the first degree. Then we end up with 16a and b. Then in the parentheses we have a, b minus 2b and plus 4. Thus we have performed complete factorization. I want to point out that we could have seen the common factor of b and taken it out immediately. However, with this approach, I wanted to show you that if there is another common factor left in the parentheses, it can always be factored out additionally. Now, we will solve another example where I will show you why we need to perform factorization. The fact is that in solving, like equations. 78 of a plus a squared equals 0. We can use factorization. We cannot solve quadratic equations since the degree of a is 2. This is known as quadratic equations. However, we can observe that the common factor is a. What results if I factor out a? Then in the brackets we have 7/8 plus a equals 0. At this stage, we will use the next rule. The product will equal 0 when one of the factors is 0. Let's write it this way. If I multiply a by 0, I get 0. If I multiply 0 by b, I'll also have 0. As a result, we use this method when solving our equation. What am I noticing? This is the first factor, and the bracket. This is the second factor. Therefore, applying our rule, I can say our product will be equal to 0 when first factor is equal to 0. Therefore, I write a equals 0. Else, the second is 0. 7/8 plus a equals 0. Then the second equation can be written as a equals minus 7/8. So we have two answers. We can say a1 is 0 and a2 is minus 7/8. Let's plug in our roots and check this claim. If so, in our initial equation, I will replace in our equality with a is 0. What happens? 7/8 times 0 plus 0 raised to the power of 2. 7/8 times 0 is 0. And 0 squared is 0. So the result is 0. This is the truth. This is right. This is equality. If I put in minus 7/8, write 7/8 times minus 7/8 plus negative 7/8 squared. It should equal 0. We will verify this statement now. 7/8 multiplied by negative 7/8 equals negative 49/64. Now negative 7/8 squared. Pay attention to the sign. What will the outcome be? Let me write it here. Negative 7/8 squared. What does this mean? It is negative 7/8 times negative 7/8. Minus 7/8 times minus 7/8 equals 49/64. A negative times a negative will be positive, a plus sign. Adding 49/64. If I add negative 49/64, with 49/64 the result is 0. We have achieved a correct equality. So we solved this equation right. Next time we will keep solving problems where we will factor. For now, our lesson is over. Goodbye, until next time.